This lesson will explain how to solve linear equations when there is an unknown on both sides. You can see with this equation that there is a pronumeral on both sides, so it's 8x plus 5 is equal to 6x plus 11. So we need to be able to simplify the equation, and we use the exact same methods as we would if we were doing an equation that only had an unknown on both sides. So still think of it like a balance scale. Whatever you do to one side, you do to the other. So if I look at this, the first thing I'm going to do is I'm going to get rid of probably the smaller term first in this case. I think it might be easier. Either way you do it, it should work out. So in this case, I'm going to take away 6x from both sides, so it'll cancel out. So in this case, 8x take 6x, I'm combining the like terms so they're next to each other, plus 5 is going to be equal to 6x take 6x plus 11. So you can see that I did the same to both sides. So took away 6x on one side, took away 6x on the other side. You can see that taking away 6x from 6x will cancel it out. So on that side of the equation, we are left with 11. On the other side, 8x take away 6x is going to leave us with 2x. And then we will still have the 5. Then we can simply do the same method as we would have done previously. So 2x plus 5, and we're going to take away that 5 to cancel out that last term, is equal to 11 take 5. 5 take away 5 is equal to 0. 11 take 5 is equal to 6. So therefore 2x is equal to 6. Divide both sides by 2 to get x on its own. 6 divided by 2 is 3, so therefore x is equal to 3. Yet again, to check your answer, you're best to go back to the equation and see if it fits. So in this case, x is 3, so 8 times by 3 is equal to 24, plus 5 is 29. 6 times by 3 is equal to 18, plus 11 is equal to 29. So you can see that we have solved this correctly. If you run into an equation that has brackets and unknowns on both sides, and we first need to expand the brackets before we can try and solve the equations. So if we use the distributive law, we know that the term outside the brackets multiplies the term inside the brackets. So we're going to do that first. So 3 lots of 2p is going to give us 6p. 3 times by negative 1 is going to give us negative 3. That is going to be equal to 4 lots of p, which is 4p. 4 times by positive 5 is positive 20. And then positive 1, or add 1 on the end. So same thing, we might simplify this straight away and combine the like terms on the right hand side of the equation. So we'd know 4p plus 21. So it makes it a bit simpler. Same thing, we need to try and get some of the algebraic value or the pronumeral or the lots of p over to one side. So in this case, I'm going to take away 4p from both sides to get rid of this part of the equation. So I'm going to have 6p take 4p, and yet again I'm combining the like terms so they're near each other, take 3, which is equal to 4p take 4p plus 21. So in this case, you can see that 6p take away 4p is going to give you 2p. Take 3, in this case 4p take away 4p will cancel out, leaving you with positive 21. We'll then need to add 3 to both sides to then cancel out the negative 3. Negative 3 add 3 gives us 0, so we're left with 2p. 21 plus 3 gives us 24. If we then divide both sides by 2 to leave p on its own. 24 divided by 2 is equal to 12. So therefore, we can see the answer is 12. So let's go and sub it in and hopefully it works. So remember our BODMAS or order of operations, so back into the original equation at the top. So 2 times by p, which was 12, so 2 times p is 24. Take 1 is equal to 23. 23 times by 3 is equal to 69. So let's check the other side. P is the first thing we need to have, and P plus 5 is equal to 17. 12 plus 5 is 17. Then we've got 17 times by 4, because the multiplication will happen before the addition at the end, BODMAS. So 4 lots of 17. 4 times 10 is 40. 4 times 7 is 28, so that equals 68. Add the 1 on the end, 69. It balances. We know that we have the right answer.